So now that we know that a tangent is just a line that touches a circle at one point, now we want to learn some theorems about tangents. So the first one tells us if a line is tangent to a circle, then the line is going to be perpendicular to the radius, so perpendicular to the radius drawn at that point of tangency, which is just the point that the tangent intersects the circle. So if we look at this figure right here, we know that OX ends up being our radius, and we know that this line right here is our tangent, and X is our point of tangency. So we know that the radius is going to be perpendicular to the tangent at that point of tangency. Now, I do want to tell you, if you had a circle that was drawn like this, let's see if I can draw a circle there, and we've got the center, and let's say that we have a tangent that's out here, and maybe I had a line that went like that, or maybe I had one that went out here. These two lines right here are not going to be perpendicular to the tangent because they do not meet the tangent at the point of tangency. So these points right here are not points of tangency. So we don't know what the measure of those angles are right there. So not points of tangency. Okay, those points right there. All right, so let's keep going and talk about some other corollaries and theorems. So here, our corollary tells us that tangents to a circle from a point are going to be congruent. And here, these tangents, they can be segments. I do want to be clear about that. They don't always have to be lines. They can be segments. So here we have this point P, and if we draw a line or a segment from point P that is tangent to the circle, let's see if I can get this. There we go. And let me draw another tangent. So we'll say that this one, oops, I didn't do such a good job having that actually touch my circle. Well, I'm trying to get a straight line and it's just not quite working. Y'all just may have to put up with the squiggle line for me. Okay, so there's one line right there that's tangent to my circle. We'll say it's tangent to my circle at point B. And I'm going to draw another tangent from that same point P, but coming over here, and I'm going to say the point of tangency is point A. And what this theorem is telling me is that from that point of tangency at point A all the way to that external point P, that segment's going to be congruent to this other tangent from point B also out there to point P. And so we know that these two segments are going to be congruent. So we know that PA is going to equal PB by this corollary here. So tangents to a circle from a point that's outside the circle are going to be congruent. So now let's look at some other theorems here. So this tells us, this is really just the converse of what we just learned. So you can specify that this is the converse. And what it says is if a line in a plane of a circle is perpendicular to the radius, so if we know that this is perpendicular to the radius at the radius's outer endpoint, then this line has to be tangent. So I'm going to put another point on this line. I'm going to call it Y. And what this theorem is telling us is if OX is perpendicular to XY, then we know that XY is tangent to circle O. And remember, I can use the symbol for a circle, which is just a little circle with a dot in the middle for the center. So that's all that theorem is telling us. So we've learned a couple of theorems and a corollary. So basically, the theorem and its converse tell us that if we have a radius and that meets a tangent at the point of tangency, that they're going to be perpendicular. And the converse is if you have a tangent that is perpendicular to a radius at its outer endpoint, then that must be a tangent. That confirms it's a tangent. And then we also have the corollary that if you have tangents to a circle from an exterior point, they are going to be congruent. So they're going to have that same length. So let's go through a few practice problems together before you do some on your own. So here we have a tangent here that appears to be this line BR, and we've got a triangle. We've got two radii, OB and OA, and we know that all radii in a circle are going to be congruent. So we can go ahead and mark that, and we know we end up having here an isosceles triangle. So if it's an isosceles triangle by base angles theorem, we know that these two base angles have to be congruent. So they're going to be both 25 degrees. Now they wanted us to find the measure of angle ABR. So if you think about this, we have a radius at OB. B is our point of tangency. So we know that OB has to be perpendicular to BR. And here, if we know, so we know that's got to be a right angle. That's got to be a 90-degree angle. And if angle ABO is 25 degrees, then angle ABR is going to be 90 minus 25. So 90 minus 25 is going to give us 65 degrees for angle ABR. Now let's look at this next example here. So they tell us that we have this radius, PA, and then we have this tangent to the outside. So we know that angle PAC, that PA has to be perpendicular to AC. And so we know that angle PAC has to be 90 degrees. Now they wanted us to figure out what angle ACP is, this angle right here. And we notice that we end up having a 30, 60, 90 triangle, so that's just going to be 30 degrees, angle ACP. And then they want us to find the length of AC. Now, because this is a 30, 60, 90 triangle, that ends up making AP our shorter leg. And so our longer leg here is just going to be that shorter leg times the square root of 3. So it's just going to be 7 radical 3. And then PC is our hypotenuse in this right triangle, which is just going to be twice the shorter leg, or 2 times 7, which gives you 14. We'll go through another example here. We have two tangents that are drawn to a circle from this outside point B. We see that one tangent hits at the point of tangency of C, and another tangent hits at that point of tangency A. And by the corollary we learned earlier, we know that these two segments have to be equal. So we know that AB equals BC. Neither of them are bigger. We know that they have to be equal to each other. So you've got some practice problems to work on at this point to be able to help solidify these concepts.